Okay, cool. Hello, everyone, and welcome to our very first actual lecture of WebLab. Okay, wait, that wasn't a diss on Kenny. Thank you, Kenny, for the amazing kickoff. So to introduce ourselves, I'm Abby.
And I'm Tony.
And we are going to be your co-academic chairs for WebLab this year. So please feel free to come to us if you have any questions about anything academic related, whether that's, can we have more office hours? I'm stuck on this. Or whether that's, oh my gosh, that last workshop was way too fast, please help. Or y'all did great on this thing. Please give us lots of feedback. We really want to hear how your experience is going so that we can make it better for y'all. And without further ado, we're going to dive into the first topic, which is something that you will use over and over anytime you code anything, and that is Git. So the driving question is, how do we collaborate on code? So let's say that Tony, Nick Tisao, and I are going to be working together on a coding project. And we're trying to figure out how we're going to work on the same project all together. I propose that we use Google Docs, but with code. So there's something stored on a server somewhere, and anytime we edit it, everyone immediately sees everyone's changes.
Wait. I don't think we can do that, because let's consider the following example. Let's say that Tisao and I are working on some project, and Tisao is working on the homepage, and I'm working on something that the homepage needs to run. And one day I decided to improve that feature. Now all of a sudden, because I'm trying to work on the same feature, and all the code is on one giant Google Doc or one giant server, Tisao is now unable to work on his code. So he's going to be like, bro, what just happened? Why is my homepage not working? And it's because I'm working on the feature that the homepage needs. So I need a way, Tisao needs a way to work on his homepage without getting disrupted by my coding. And I need to code in a way such that it doesn't disrupt anyone else. So ultimately, the big problem we need to solve is we need to have independent copies of the code so that people can work without disrupting one another.
Whoa. Okay, so I get what you're saying, that people need to be able to work independently so they don't break something that someone else is working on. But like having independent copies of the code on different machines, like that's so complicated. Like everyone has their own copy of the same files? That creates so many problems. All right, this is why I think problems with local copies. First up, how do you merge changes that you make? So let's say that you and Tisao are working together, are working separately on different files, but you're changing the same file, but in different places. So maybe you're adding a function somewhere, and he's changing the formatting in the other functions. And so you need to merge those changes together. But how are you going to do that? Are you just going to like copy and paste everything?
Well, we can copy and paste everything. And also, we can just have a group chat together where we just copy and paste things in sequence, you know? So we have a log of everything we copy and paste.
Sure. Okay. Next slide. But then consider this. You're copying and pasting all the changes that Nick was making, and somewhere along the line, you ended up deleting a function here or there. And then an hour later, you go back and you realize, oh shoot, I needed those. Ain't no way you're going to scroll back through your entire Messenger chat history and find the version of the code that had the function that you needed and then undo all your copy and pasting? Bro, we need version control.
Well, okay, get this. What if Tisao and I, maybe there is an issue if we're trying to find something that broke somewhere and we have to look all the way back up our message history. But let's say that Tisao and I are absolute homies, that we're perfectly in sync, and we can just have this system between us.
Okay, sure. So if I give you the benefit of the doubt on that one, there's still a problem. Because I'm also working on this project. And I was a normal human being and went to bed at midnight last night, and I didn't see all the changes in the group chat that you guys were making. And so now there's this version of and I built a giant new feature off of that. So now there's this version of the code that we had from yesterday, and then you and Nick made all these changes late last night, but then I was also making these changes for the new feature that I was building. And so now which one of these versions of the code is the most up-to-date version?
Well, it's kind of your fault for sleeping at only midnight, so I think we should keep our changes since we coded a lot more. We coded like 300 lines of code last night.
Excuse me? What if I coded 301 lines of code?
Oh, I know what we could do. We could use something. Oh, so to review, we need independent copies in order to keep our changes from interfering with one another. But if we have independent copies, we run into a bunch of issues. How do we actually merge the changes that we have with one another? How do we keep version control or keep running versions and have a proper history of all the code that we ever write? And how do we agree on which code is the most up to date? Oh, I know. We can use something called Git.
Oh my gosh, I completely forgot about that.
Abby, would you like to tell them what Git is about?
Of course. Okay. So at its core, all Git does is it keeps track of changes. So it uses some fancy math to say, okay, if you have this old version of the file and then you change all these things and then you have a new version, what is the difference between the old version and the new version? So if I have this example file and then I add something and then I remove something, Git looks at version 1 and version 3 and says, oh, okay, I can see that I added this and I removed that. And this is the information that Git stores. Okay, so before we move on and actually talk more about what Git is doing, we are going to get you guys set up with a Git repo on your laptops.
So first of all, this might be a little too introductory for some of you, but we want everyone to start at the same step. So first, going to start off with a little bit of terminal fluency. So for on my Mac, I'm on a Mac, I'm going to use a terminal. If you're on Windows, you're going to use Git Bash. Hopefully you have it installed. If not, it's really fast to catch up on, so it's okay. So on my Mac, I'm going to do command space, and it's going to bring up something called the Spotlight, where I can look for the terminal and open it. Now I have this terminal that can interact with the file systems on my computer. The first command that we're going to learn is called cd, also known as change directory. This basically moves us from one folder into another.
Wait, pause. Can you guys see in the back? No? Okay, can you zoom in?
Yeah, I'll make it fast.
Terminal. Okay.
Hopefully that's big enough.
Yeah.
So cd will be able to let us change from one directory to another. Another thing that we would need to learn how to do is make folders. So I can do something called make dir or make directory, and I can call this maybe like WebLab example. Now something else we could do is list all of the current files in our directory, and we're going to do that with ls. I'm going to do that with ls, and we see that there are a lot of different things here. We have my school stuff, we have, a personal diary, some examples, and then we can still change into that new WebLab directory that we have made. And as you can see, if we type ls in it, it's empty because we made an empty folder. Some other special characters that we need to know is ... Dot basically refers to the parent directory, or the folder that's containing the folder that I'm currently in. So if we do cd ... I go back one step. So if I go back one step, I'm going to go into my original folder. If I list again, I can see that I can start up where I originally was. I could also have the one dot character. One dot just means the current directory that I am currently in, which means if I change to the current directory, nothing's going to happen since I'm just staying exactly where I'm at. So I'm going to go into the WebLab example that I have, and I'm going to type git init. What git init does is it creates a Git repository for us in this folder, basically an environment where we can finally start using Git. Hopefully we also have Visual Studio Code opened up or downloaded. So if I open Visual Studio Code, on the top left, you can open a certain folder, and you can actually select the folder that you created, and we have ourselves a little code editing space. So now we can move on.
Okay.
So now it's your turn. So in your terminal, try creating a new directory, changing cding into that directory and basically going into it, and try turning that directory into a Git repository using git init. We'll give everyone about 1 minute to do this, and it's pretty necessary for the rest of the workshop.
Mm-hmm. And just a reminder that if you get stuck, you can hop on the help queue using weblab.is/queue, and one of the staff, we have lots of staff here, will come and help you. Please do if you're stuck, because we need this for later on during our lecture. Or you can also just raise your hand. That works too. Can you give me a thumbs up if you're completed with this?
And then
Okay.
maybe a thumbs down if you still need a little bit more time to do so. Oh, so the new directory command, so we have all the commands referenced on this right-hand side. CD for change directory, ls for listening to directories, mkdir for making the directories, and git init for turning the directory you're inside into a Git repository. So we want to make the directory, CD inside of it, and then type git init.
Okay, raise your hand if you need more time. All right, cool. Let's
Looks
move
like
on.
we're good to move on. So now we're going to actually talking about making changes and tracking changes using Git, using the commit history, the working copy, and the staging area. So let's say that I am a Core 6 student and I'm just making some code changes here and there. So maybe in a certain file, in cat.py, I'm going to delete the line, I like cats. How dare he? Now I'm going to go into another file called woof.py and add I like corgis. And then I'm going to go into another file, or the same file, and I'm going to add I like huskies. And then in another file called tony.js, I'm going to add something like I like Andrew. So we basically have a bunch of code changes that we're working with here. We're also going to have something called a commit history. You can think about this as developer checkpoints as you are making your code. So we can have also some messages that describe what these code changes are about. These are going to be the main thing that's going to help us maintaining version control. Now, how do we actually take these code changes and actually contribute to the commit history? Well, we're going to have something called the staging area. The staging area is essentially a makerspace for these commits in order to make these checkpoints for ourselves. So I'm able to take any subset of the code changes that I've made, put them into the staging area, and then box it all up and put into a commit, and maybe adding some package or some message to it that will describe what that commit is about. So I had the code I wrote was about liking corgis and liking huskies. So the commit message I wrote, or the little sticky note on top of it I add, is about dogs. So I'm going to demonstrate this real quick. I'm going to go into VS Code and create a new terminal. So this will be at the top and right here, new terminal. I'm going to make this also a little bigger so, oh my gosh, we can see. Maybe resize some of this real quick. So in Visual Studio Code, we're allowed to make new files. So I'm just going to create an example file here. Maybe just a text file will work for now. And the first thing I would do is make some code changes. So I'm going to be making some code changes. And then I'm going to do Command S to save these code changes into my working directory. Now, if I type something like git status, what git status does is it gives us a broad overview of what this current picture looks like. So if I type git status, the things in red are things that code the changes that I made over here that are not in the staging area. To put them inside of the staging area, I do git add, and then the path to the file that I want to track, such as example.txt. Now if I git status again, I see that it is now in green. That means that I have taken the code changes that I made and I put them inside this open box of the staging area. Now, if I feel like I'm confident that I want to create a checkpoint or a timestamp right here, I do git commit and then -m for message and write a little memo about what this is going to be about. So, made some code changes. Now, if I do git status, I notice that it says there's nothing to commit because everything that I boxed up and put in the staging area, I have transformed into a closed box, made into commit, and put it onto the commit history. So if I say something like git log, I can see that there is now a log of the commits, and there is a commit right here on the bottom that says made some code changes. So I'm going to give us some time to try this yourselves. So try making a new file and making some code changes, staging those changes, and creating commit, and see what the resulting log looks like. Be sure to use git status whenever you can to see the actual process of this being happening. I'll give us probably around
1 minute.
a minute or two to do so, and we'll check up on how we're doing. Also, all the commands that you need are on this side over here, all the handy commands. So diff status add and commit.
We probably don't need diff, but whatever.
Probably don't need diff.
Yes. We were going to talk about that later and forgot to take it off the slide. So do not worry about that.
Yeah, don't worry about git diff for now. I guess right now all you really need is add commit and status on the way, and checking the log of git log.
Mm-hmm. What's up? I'm guessing that means that you either haven't done git init. No, I think that means that you probably don't have git installed properly. Oh, okay.
Are you on a Mac or on a... Can we get a staff member to help him out real quick? Thank you, Andrew.
Raise your hand if you need more time for this. Okay, we'll give like 30 more seconds. All right, checking in again. Does anyone need more time? All right, cool. I think we are going to move on, but feel free to, it's okay if you haven't finished this.
Yeah.
Oh, oops. It's okay.
Yeah. Anyways, so we're going to have this timeline of like your checkpoints, your developer checkpoints of commits, and abstract this set of packages and messages into something called an object graph. So each commit, instead of looking like a box, is actually going to look like a little circle or node. And each commit has some properties to it. First, it has some unique commit ID, or like a hash, that resembles like what exactly is it. And then it has some message that we initially wrote about it to help us remember what this code change is about. For example, about dogs. As we could see in our Git log, it has these two properties. It has a really long commit ID that looks a little scrambled, and also has our little message to it. So let's also considering the following example. Let's say that I'm just vibing and I'm working on my new and improved homepage. And all of a sudden, Andrew wants me to fix a bug somewhere, maybe on like another homepage. And me, being the absolute simp I am for Andrew, says, anything for you, Andrew. Of course I'll help you fix your bug. And then let's say that Abby just for some reason just got dumped recently. And for some reason she's really mad at me. And she says, Tony, guess what? We need a web lab Tinder feature tomorrow. And you're the one that has to do it. So all of a sudden, I'm just really stressed because I have to use this object graph and use version history and version control. But how do I work on multiple features at once? So I'm going to introduce the concept of branching. So I'm going to make a demonstration about branching. I'm going to teach you how to create a new branch and how to switch between branches. So if we do something like git branch, we can see all the branches that we currently have. Currently, we only have a branch called main. I'm going to make this a little bigger for you guys. Main right here. Green highlights means that we are currently on that one, and then it lists all the ones, and we only have one so far. And to create a new branch, let's say I want to create a new branch called web app Tinder, I can do git checkout -b, and then the name of the new branch, such as web lab Tinder. Now, if I type git branch again, I can see that there are now two branches that I have, one called main, and the one highlighted in green called web lab Tinder. Now, to switch between branches, I'm able to say git checkout and any of the other branch names. So I could be back at main. So now it's your turn. Try creating a new branch and maybe even try staging and adding and making some code changes and making some commits and check the log. And then try checking out back to the main branch and check the log again and compare the two. And think about and explain to your partner, what do you think the object graph actually looks like? Once again, we have all the handy commands on that side, git branch, git checkout B, and some of the previous commands that we have used.
Also, This is a good moment during lecture. If you are not sitting by someone, I would highly recommend just looking around and finding someone near you who you can join, either in partners or in groups, so you can talk to each other about what's going on.
How much time do we have?
Let's give 2 minutes.
2 minutes.
2 minutes and then we'll check in.
Should I demo this?
Huh?
Should I demo this real quick?
I think we're
we're low on time.
short on time.
Yeah. What's your question? So master is the old name for, so whenever we create a Git repository, there is a default branch that we have. Master is just what they used to call it, and main is what they currently call it. Does that answer your question? Is it bad?
I don't think so. I think it should be fine. I mean, it might mean that you are on an old version of Git,
Yeah.
which I don't think should cause problems.
Ideally, we would have, I think it's ideal, just so you don't run into problems later, to have a newer version that has main as your default. It might be on the Git website.
Yeah, I mean, on the installation guide, I think we probably have the most recent version
Yeah.
of Git on. Yes, what's your question? Add in commit.
Yeah. So if we go back a few slides, my goal is to create some type of version history, like a sequence of checkpoints such that I can always look at my code and see what I have. So the commits are the solidified checkpoints that I have made. Staging is what I do in trying to make a commit. What changes do I throw in there?
So wait, here.
So what git add does, it adds code changes into the staging area. And what git commit does, it takes all those code changes in Git that is staged, closes the box, and adds it at the end of here.
Oops. Okay. Raise your hand if you still need more time for this. Okay, I think we are going to move on then.
So what exactly is happening in the object graph? Well, we see, I think Abby's going to show.
Yeah. So basically what happens if we branch. So for example, we're working on main. Okay. And we're making some commits. So this is our first commit, and this is our second or something. And then we decide to branch. So we're going to branch off from here, and then we might make some more commits. And then let's say we go back to main and we decide to make some commits on main. Maybe we're just like making small bug fixes and this branch is for a feature. Then if we're on the branch and we do git log, then we'll see this sequence of commits. And then if we're on main and we do git log, then we'll see this sequence of commits. And so the branch won't see any of the commits on main that were made since we branched off from it. It's pretty intuitive. Okay. So then what we want to do is at some point we want to be able to put these back together. If we made some bug fixes, but we also developed a new feature, then when we're working, as soon as we're done with our feature, we want to combine these changes together. And so how we do that is with a merge.
So I will demonstrate merging for us. Let me just make this bigger. So first, I'm going to go into my WebLab Tinder feature branch, and I'm going to make some sequence of commits here. So let's say I have tinder.txt, and I'm going to say this is about WebLab Tinder. I do git status and see that I have some uncommitted changes. So I do git add and the file name, tinder.txt, to stage it. And then I'm going to do git commit -m, added Tinder things, to make an official commit. And now that if I check the log, I see that at the top of my log, I have added Tinder things. If I check out back to the main branch, I see that in my log, it is not there. So to merge it on the branch that I'm currently on, I'm going to do git merge WebLab Tinder. And what this does, it merges WebLab Tinder into the branch that I'm currently on. So now, even though I'm in the main branch, I have all the changes from WebLab Tinder. And if I do git log again, I see that the WebLab changes from WebLab Tinder is now moved onto the main branch.
So we're going to go into a lot more detail on merging and how that works, and you're going to try it out in our second Git lecture, which is going to be on Friday. But for now, we're just going to go on a high level. Basically, what merging does is we're being a little hand-wavy with it. It takes the changes from your branch, the changes from main, or whatever you're merging into, and combines them together with a merge commit. Well, how do we collaborate? Because notice that we were talking about object graphs, we were doing version history, committing, etc., all on your laptop. So this does not connect with the web. It does not connect with anything else. So how do we work together? Basic idea is that you have on your computer a representation of your project. And we have an object graph, which sort of represents the history of your project. And what we're going to do in order to collaborate is we're going to take that and we're going to put it on a server online. So that's what GitHub does for us. It just hosts our project and the object graph online. And so, Tony, how do we keep what we're doing on our computers synced up with what we have online?
So this is just a preview of Friday's lecture of Git for collaboration. So this is not an enough explanation. This is just an idea of what's going on and just a preview. So let's say that T-Cell has this object graph and he adds it into GitHub. And I want the same exact copy so that I can collaborate with him and keep in sync with him. So I have a command called git clone, which basically takes the object graph on the remote server, and I basically clone it onto my own computer. Now let's say that I want to contribute to this basically centralized, shared object graph. Then I can maybe make some code changes, do git add to stage it, git commit to commit the stage differences, and I could do something like git push to update the server with my version. Now T-Cell does not know that the server is updated, so he has to do a quick look. So he does something called git fetch, which basically he looks there, he looks back, he looks there, he looks back, he looks there, he looks back, and be like, oh, I think I know what the difference is. And then he does git pull to finally get those changes that I made back into his computer. And let's say that he messes up real hard. So we do something called git reset hard to basically wipe everything we have done up to the latest commit. We will go much more into depth about Git for collaboration on Friday, so stay tuned.
Yes, that last part you do not need to be fully following. This is just a preview of what's going to come and also what we're going to be using in our workshops.
Yeah, so
cool.
Thanks. Cool.
That was Git. And next up, we're going to have HTML and CSS.
Yeah, Git is very difficult to understand the first time you touch it, but you will pick it up throughout the first 2 weeks of WebLab as time goes on. Please come to office hours or post on Piazza. Please talk to us if you are confused about anything that we have said so far so that we can help you and get your project going.
Do you need to unplug?
Yeah, I think...